We learned that a direct variation is a linear equation that is represented like y equals kx, which is like y equals mx plus b, is just that the b is 0. That's why there is no b. There's nothing after the x term. And the m is actually k. Right? The k, we said, is a constant of variation. So if a direct variation is y equals kx, if you solve that for the constant, for the k, you get k equals y over x, which means x and y change. They're variables, right? There's going to be infinitely many points on this direct variation. But if you divide y by x, it's always the same thing on a direct variation. So if you saw a problem like this, which I don't know that you will. I know that like in the department, we're more thinking that this kind of thing will come at the beginning of chapter 9 when they do the other kinds of variations. But it's possible. And there's going to be some questions in the review package anyways. So you won't be confused by what you're seeing. It's actually not a hard problem to solve. So they got to tell you first that it's a direct variation. So there's always a statement at the beginning that says, okay, this is direct variation. Right. Then they got to give you a 1 point that you know both the x and the y. And then they're going to ask you for a missing variable for another point. Well, if you know that the constant equals y over x, you set it up like a proportion, right? Set it up like negative 51 over 27. That's the y divided by x equals, we want to find x when y is negative 17, negative 17 over x. You can set it up like a proportion like that. And then how do you solve a proportion like that? Do you remember the strategy? Cross multiply. That's when you cross multiply. Right? It should be that, let me say, cross multiply. Right? It should be that negative 51x equals negative 17 times 27. And that's a basic algebra thing that you can solve. So notice that I have to be careful. Definitely k equals y over x. So on this level here, both fractions in the numerator, there's a y. Both fractions in the denominator, there's an x. Right? You got to be consistent, right? Y, y, x, x. Now, if all you're trying to do is find the missing variable, if you make a mistake, if you like flip both sides and do x's over y's, you'll still get the right answer. Right? Because when you do the cross multiply, it's still going to give you that exact same equation. But you got to be consistent. If you did y over x here and x over y there, then you're going to get the wrong answer. But it's kind of forgiving in that way. That if you make a mistake and you do x's over y's instead of y's over x's, you can still solve it and get the right answer. How did you solve this? Divide by negative 51. And 17 goes into 51 3 times. So that's like 27 over 3, which is 9.